Assalamualaikum and have a good day. My name is Azika Najiha binti Muhammad Kamal Arifin, MA 18277, and I will explain about the introduction of experiment 4. The background of this lab is a pump can be defined as a mechanical device that when inserted into a pipeline, converts the mechanical energy supply to it from external source into hydraulic energy, causing a fluid with a lower potential to rise to a higher one potential flows. They are often used together to increase flow or pressure above what a single pump can do. So the problem statement of this lab is the pump draws water from a storage tank and delivers it through a flow control valve and a venturi or counterpart in the tank. Changing the setting of the flow control valve change the resistance of the system and thus change the operating point on the heat characteristics of the pump. The objective of this lab is to demonstrate the principal operating characteristics of centrifugal pump in series, parallel, or single pump operation. To determine the pump characteristic curve of pump in series and parallel configuration and single operation, and to determine the pump power. Next, the scope of this experiment is only used to determine, calculate, and analyze the individual pump as well as the parallel and series. We will also use series and parallel pump device for this experiment. Many other parts such as control valve, processor, and others to measure the data according to each experiment and given configuration. So that's all from me. Thank you.
Assalamualaikum and good day. My name is Siti Rana binti Abdul Rahim, Matric AD, MA 18240. I will continue our presentation on the second chapter, which is the theory. Considering the pump in this figure, the work done by the pump per unit mass of the fluid, which gives the equation of W over M, where W is the work done and M is the mass, will result in the increase of pressure head per unit mass, increase in velocity head per unit mass, and also increase in potential head per unit mass, which gives these three equations. And when applying Bernoulli's equation between point 1 and point 2 results in the summation of these three equations, the pressure head, velocity head, and potential head per unit mass is equivalent to the work done by the pump per unit mass. And since the difference between elevations and velocities at point 1 and point 2 are negligible, the equation is simplified into this form, where this will be negligible. And dividing both sides of this equation by acceleration due to gravity, which is g, gives this equation, and the right side of the equation is also equivalent to the manometric pressure head (hm). Therefore, the equation is simplified into this form. Next is power and efficiency. The total power P of the pump results from the volumetric flow Q and the achieved pressure difference between the delivery and intake sides of the pump. So basically, the power of the pump can be obtained from the product of the achieved pressure difference and volumetric flow Q. The input power, which is P in, is usually the electrical power, and the output power, which is PO, is dependent on the pump efficiency. So the pump efficiency equation gives us this form, which is P output divided by P input, where P output can be obtained from this equation and P in can be obtained from this equation. Pumps in series. A single pump may be insufficient to produce the desired performance. Therefore, combining two pumps could increase the pumping capacity of the system. When two pumps are connected in series arrangement, the fluid will pass through the first pump and then through the second one. Pumps in series is ideal when pressure is the input parameter. When pressure increase is needed. To increase the pressure, then use pumps in series and the flow rate throughout the pumps remain unchanged. So this will give us this Q total, QT, equivalence to Q1, equivalence to Q2, Q3, and so on. So the flow rate will remain the same, but the pressure will differ. It will not be constant because the pressure is going to change from P1 over here, and P1 here will be less than P2 over here, pressure over here, and P2 will be less than pressure, the final pressure, P3, and so on. So as you can see, we are increasing the pressure way much more than in the parallel arrangement. So here is the system curve, and this is the single pump, and this will be the normal. So here is the system curve. So here is the system curve. This will be the single pump, and this point right here is the normal operation. But when the pumps are in series, the head will be increased. The difference. However, for pumps in parallel, it is ideal when the flow varies. That means if you are changing, you can always increase or decrease the flow rate because you are going to split it, so the load is relatively lower in general. So the pressure is maintained and the system's capacity is increased, which means the quantity or the flow rate increases. That's why Q total is equivalent to Q1 plus Q2 plus Q3 and so on. So the pressure remains the same. So instead of increasing the pressure that much as it will be in series, we'll be able to process more fluid flow. So you are sacrificing pressure increase to get more fluid flow. So this is the system curve. This is system curve, and here is one pump or single pump. And instead of having one pump right here, you have two pumps connected in parallel over here, where you can see that let's say this is Q1, and this is Q2, the quantity of flow rate increases using the same head of pump. So that's why Q total equals to Q1 plus Q2, Q3, and so on. So previously, we increased the head in the series arrangement, but now we are increasing the flow rate. That's all for me. Thank you so much. I will pass this presentation to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Silman bin Alinsha, ID MA 19033, and today I would like to continue our presentation to Chapter 3, Method and Procedure. (3.1) Apparatus and Material. This system comprises two identical centrifugal pumps that are connected together via pipes. Manual valves make it possible to switch quickly between series and parallel operation. Manometers indicate the pressure at all important points in the pipe system. The pump characteristic can be recorded. The hydraulic power output of the pump can be determined. The water supply and volumetric flow rate measurement are provided by the apparatus. This is the figure for the apparatus. Next, 3.2 experiment procedure. In this lab, we conduct 3 experiments. As you can see, experiment 1, single pump operation. This is a figure for experiment 1. Next, for the next experiment, experiment 2 is for series pump operation. As you can see, this is a figure for series pump operation. And lastly, experiment 3, parallel pump operation. As you can see, this is the figure for the parallel pump operation. With that, I end my presentation. Thank you.
Assalamualaikum and very good morning to lecturer and friends. Today I want to present about the chapter 4 for the result. This is a table for the single pump configuration, and then this is a calculation for the net head, and then this is a calculation for the power output, and then this is a calculation for the efficiency. And then this is a table for the series pump configuration. For the net head calculation, we must calculate the H1 head and H2 head, and then for the net head, we must H1 plus H2. We get the net head. And then this is a formula for the power output. And then this is a formula for the efficiency. For the series pump, we must P in equal and multiply 2. And then this is a table for the parallel pump configuration. We must for the calculation for the head, we must find the head 1 and head 2 from the formula, and then we must plus H1 and H2 divide 2. We get a net head. And then this is a calculation for the power output. This is for the calculation for the efficiency, and then efficiency for the P-in, we must multiply 2. This is a pump performance curve graph that show the performance graph, the relationship state the single pump heat is inversely proportional to flow rate. And then this is a series pump, and then this is a parallel pump, and then this is a discussion. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afaris Afi bin Abdul Aziz, MA19021. Okay, for the conclusion, in conclusion, we have learned to design a complete measurement technique for fluid flow. The measurement is taken using virtual instrument, the Lab, and the virtual instrument modeling is used to get precise value using strain and flow sensor. And in the experiment, we can see the performance curves that show off that net head decrease as well as the flow rate increase as a result of arrangement of the pump in single, parallel, and series configuration. The capacity of the pump was statically enhanced. The volume of flow rate is approximately identical to that of single pump when it is linked in the series, but the net head increase when many pumps are linked in the series. And lastly, the net head rise, and with it, the volumetric also increase. Thank you very much.